I'm James. I think I've already been introduced, so I can skip that part. I've been working with Clojure for about 7 years. So I've developed a few web libraries. Some of you might have used it. And I'm currently working freelance as a contractor in London. So I'd like a show of hands. How many of you, before today, before you actually looked at the Clojure X schedule, had heard of Duct? Oh, so about a quarter maybe. How many of you are actually using it? There's a couple in the back. Okay, so that's good. We have. I won't be treading old ground here. Okay, so what is it? So Duct is a Leiningen template. It's a small supporting library, and it's a set of coding guidelines. And I guess those three things combined we could call a framework. So what's the big idea? Okay, so it's a framework. We don't often see frameworks in Clojure, so why have it? So as projects grow, they become more intertwined. They basically become more complected. When I start working, I don't know if it's the same with you guys, but when I start working on a project and it's got 0 lines of code, that's almost when I'm the most happiest. And when a project's got over 10,000 lines of code, I'm not so happy. So Duct is designed to solve that problem. It's designed to make me happier with a project with 10,000 lines of code. And the big idea is uncompromising simplicity. And what do I mean by simplicity? Well, if we take a look at these two things, which one of those looks more simple? On the left or on the right? It's probably the one on the left, right? And next question is, well, what makes that simple? Because they've got the same number of lines, but intuitively we kind of see the left as being more simple and the right as being more complex. So because they've got the same number of lines, it's not cardinality, it's how they interconnect. So the left is simple because it's got 3 interconnections, and the right is complex because it's got 12. So this is from this is a definition which was first proposed by Hickey in his talk "Simple Made Easy," and he basically says that simplicity is a lack of connections, a lack of intertwining, and complexity is lots of things which are intertwined. So let's go back to this. So we've covered simplicity. What do I mean by uncompromising? Well, in programming, we tend to make rules, and these rules are there to be broken. So when we use macros, one of the first things you might hear is, don't use macros, except when you need them. So in this case, don't make things complex, but sometimes you need to compromise, right? So we can't be simple all the time, but we can be simple by default. We can be simple unless we really, really need to start making things complex. Okay, well, maybe we've accepted the fact that we need to build stuff simply. How do we do it? So let's start with a basic example. And this is one of the simplest things I could think of. So at the top, we've got a database, which is hard-coded. Then we've got a find user function, and then we've got a handler application down the bottom. So here we've got a global variable. And if this is a sort of representation of a program which is just written with pure functions, then this is an example of a program with global variables. Global variables can be accessed by any function in this nice tree, so we no longer get this simple flow of data from the top to the bottom. We have this data which is sort of intertwined with our entire program. It's complexity, right? Because we've now got all of these links from the global menace up in the top right to all of our pure functions. And ideally, we want to avoid that sort of thing. So global variables ain't simple. So if global variables are something we want to avoid, how do we define configuration in our application? So how are we going to pass configuration, like the database, into our handler? Well, one way I've seen it done is dynamic variables. So I've seen this approach in some applications, and it sort of goes a little bit like this. Here we have the global variable, but what if we make it a dynamic variable? And then we can create some middleware here which binds the database to this dynamic variable. And this means that the dynamic variable is only visible in the actual thread itself. So this limits the complexity somewhat because it's not accessed by every single function, but only functions within that binding. Only functions called within that by the handler within the particular thread. But it's still complex to thread, right? So we've reduced it from being complecting everything to just complecting everything in the thread. So it's a little bit better, but not great. The other way I've seen it done is to add the configuration to the request map. And the way this works is we have the application here, and instead of just passing the parameter, we also pass in the database. So the database is kind of entwined with the request map. And the way we do that is we just have some middleware, and we associate the database with the request map, and then up here we can pull it out. So this is, again, a little bit better, because we're not intertwining it with the entire thread. We're just passing it into this route here. So find user no longer is intertwined with our top level variable. So it's a little bit better. But it's still complex, the configuration request, right? It's still not perfect. And it also seems intuitively wrong to put the configuration in the request map, right? I mean, they're two different things. We've got the request, which is coming in. We've got the configuration, which is only should be only evaluated once. So what's left? Well, in Clojure, maybe the best solution is to use closures. And the way that would work is something like this. So we have the application. So this is the function we saw earlier. And in order to make this a closure, first of all, we pull the roots. So def roots is just short for def and roots, funnily enough. And once we've got this single level handler, we then just make it into a function and we pass it in the database. So here we have a function that takes in the database, takes in a configuration, and returns a handler. And in Duct, this is called an endpoint. And so that we can pass multiple configurations, because we might not just be passing a single database, but we may be passing things like cache, queue, multiple configurations, we just make it to a map. So we pass a map to a function, and that returns a handler. And the advantage of this is that this thing is only evaluated once, and it's simple because it's the minimum complexity. So this DB here is only used here. Outside of here, this falls out of scope. So it's the minimum complexity. So closures are the least complex thing we can use. And an endpoint in Duct is a function that produces a handler from a config map. So this is the main abstraction in Duct, right? So Duct introduces this abstraction, it calls it an endpoint, and all it is a function that produces a handler from a configuration map. So okay, maybe that's okay. But how do we deal with temporary files? Or how do we deal with open connections? Or how do we deal with background threads? Because all of these things are things that have a life cycle. So we've talked about static configuration, right? So a static configuration with a static database spec we're pulling in. but what happens when we need to clean up after ourselves? What happens when we need to delete our temporary files or close our open connections or destroy our background threads? So what we need is something with a life cycle. We need to extend our configuration map with something that has a start and a stop. So something like this. So we have a protocol. We'll call it life cycle. We have a start and we have a stop. And the start can open the connections and the stop can close them. Or the start can create the temporary files and the stop can delete them. And it's basically just initiate and clean up after ourselves. So some of you might be looking at it and going, this looks kind of familiar. And that's because it's taken from Stuart Sierra's component library. So again, I kind of want a quick show of hands. Who here has heard of Stuart Sierra's component library? And it's pretty much everybody, which isn't surprising because I've just remembered that lots of people have mentioned at this conference. But that's what it says in my speaker's note. I've got to ask the question because it tells me to. So who has actually used it? Okay, so fair, maybe about half. Okay, so here I'm kind of preaching to the choir maybe a little bit, but Duct uses the component library. So we've got endpoints and we've got the component library. So before we were talking about the configuration, and the configuration produces these endpoints. So the configuration goes to the endpoints. With Stuart Sierra's component library, we can introduce a system between the two. So instead of just passing the configuration to the endpoints, we pass the configuration to the system, and then we pass the system or the components to the endpoints. But how do we make a system? Okay, so how does this actually work in practice? Because this is a fairly sort of top-level overview. How do we actually make a system? So here we have 3 endpoints. So you can have multiple endpoints in Duct. And, well, what's going to happen in the system? Well, we need something to kind of pull these endpoints into the system. So we need something in the system that references these endpoints. In other words, we need a component that references the endpoints. Or to put it another way, we need to promote these endpoint functions into a component. And we can do that fairly simply. So this is an endpoint component. It's pretty much exactly how it's in Duct. When we start the component, we just run the endpoint function, passing it the component itself. And components are just maps, right? They're just records that implement a protocol. So the component itself is the configuration. And then we associate the handler return from endpoints to roots. And when we stop the component, we just dissociate it. Okay, so pretty simple. We can pretty easily sort of promote a endpoint function into a component. So we've got this here again. So we know that these are endpoint components and they link to these endpoints. But we've still got multiple ones of these, and we've only got one sort of output, right? So we want to put all of these into one HTTP server. So we need something to combine these endpoints together. So some sort of overall handler which connects all of these endpoints up. And that looks a little bit like this. Not exactly like this, because in Duct itself, the handler component does a lot more. It handles middleware and other things. But it roughly works like this. So what it does is it looks for all of the dependencies in the component, and it keeps those which have roots. So it looks for any dependency which has this roots key. And if it finds them, then it takes all of the roots and uses the Clojure roots function to combine them all together. And that produces the overall handler, which it then associates with the component. And when we stop, we just disassociate the handler. So again, this isn't exactly how Duct handles it, but it's close enough. So once we've got this handler component and we've got an endpoint component, we can put these together in a system. So here we have 2 endpoints and one handler component, which we called app. And component works by declaring dependencies between components. So here we're saying the app component has got a dependency on foo and bar. So Duct will make sure that these things are started before starting the handler. So these two things depend on, or this handler component can't start, it can't do anything before these endpoint components work. Now in component, this is actually unordered. Even though it's a vector, dependencies aren't ordered. So Duct does it by alphanumeric. So as it happens, bar will be put in here first, and then foo because B comes before F. But you can specify the endpoint order exactly. So you can say, actually, I want foo to appear before bar. And usually this doesn't matter because your endpoints will be pointing to different paths. But if there is any conflict between them, or you want one endpoint to be checked first, then you can by using this. So that's the system. We've got the endpoints. We've got the handler which joins them together. How do we actually configure this thing? So first, well, where does configuration come from, right? We know that the configuration is maps, and in previous examples we hard-coded the map. But in a real system, where did it come from? Well, the configuration in a real system isn't hard-coded, but we probably have a set of default values. And maybe we pull the configuration from the environment, or from some configuration file, or even from a network service if we're operating in a cloud. So we have something here which for our configurations, and we can have multiple configurations. So we can have a default configuration and a configuration from the environment. So we need some way of merging those configurations. So we need some way of taking the default configuration, taking the configuration from the environment, taking the configuration for network, and merging them all together somehow. And it turns out that there's already a solution for this. And Leiningen pops up and says the solution is meta merge. So what I've done is Leiningen has a internal function called meta merge, which it uses for merging its profiles. So if you've ever used Leiningen's profiles, you'll probably be familiar with how meta merge works. And ICP took that code and pulled it out in its own library, and that's what Duct uses. And in practice, it looks kind of like this. So we have this default configuration, which just declares a default port. And we've used this metadata here, displace, to say that this default data should always be replaced by something else. So we'll only use this as a last resort. And then we have this environment configuration, and we just pull this port from the environment, so from an environment variable. And then we meta-merge the two to produce our final result. So before I said that globals were a menace and shouldn't be used. And here I am using them. So what's going wrong with that? Well, globals are okay as long as you don't use them as globals. We could replace these things with a let clause. I mean, so long as we're passing these in at the top level, so long as we're not using them as globals or sort of trying to insert them deep into our application, effectively, as long as they don't jump the queue, it's fine to use them. And it's sometimes useful to have them as variables that we can look at in the REPL, because the moment we start using a let clause, we lose the ability to just arbitrarily check them. So they're global variables, but we don't use them like global variables. So here's our sort of overall diagram again. And here's the merging of the configurations. And that's Duct. So that's the entire system. We have some configurations, which are just maps, and we pull them from somewhere. And by default, Duct pulls them from the environment and has a default set of configurations. But if you wanted to use some other configuration system, like Nomad or something like that, you can. As long as it produces a map, that's all that matters. Then we pass these configurations into the system collects all of the endpoints, and then it passes the dependencies that the endpoints need. So each endpoint will only receive the endpoint, the dependencies it needs. So if one endpoint needs the database, it'll get the database. If another one needs the database and the queue, it'll get that. So what we're doing is we're minimizing what everything can see. We're operating on a need-to-know basis. The endpoints only need to know the things in the components in the system which they're dependent on, and the system is only dependent on this one, on the merged configuration. So at this point, I'd like to recommend some talks. So if you're interested in this, I'd recommend checking out Simple Made Easy by Rich Hickey if you haven't already. And also, Stuart Sierra has a talk called Components, Just Enough Structure. So if you're using components, I'd recommend that you listen to that talk. And the things I don't cover in this talk are kind of covered in there. So now let's move on to a quick demo, if everybody wants a demo. So let's see. I now have to mirror my display. And can we see it? Yep. Move on to item. Let's, how big is that? It's could be bigger. Okay. Is that big enough? Okay. Okay, so let's do something with Duct then. So it's a lining template. So we use line new. The name of the template is just Duct. We'll create a new project called foo. So after that, the project name occurs. And then we'll give it some profiles. So like if any of you have used Luminous before, you will know that there are, this uses kind of the same syntax. So you use plus and then the name of the profile you want to use. So we'll say, okay, this is, we want it to be a site. That includes site middleware and things like that. We want it to have Clojure script, because why not? And we'll give it an example. So now it's going to go off and actually build the thing, because it's line again, it's a little bit slow. So now we've generated a new Duct project. So we'll cd into that. And those are the files there. We can run line setup. It's not necessary to do this. This just creates local configuration files. So one of the things I've done with Duct is that you can have local configuration files that add your own profiles. So you can add your own dependencies which aren't in the source files, which aren't in the repository. And you can also add in your own code which isn't in the repository. So you can really customize this without affecting what your teammates are doing. So you can see dev.local is only run locally, and profiles is only local as well. So once we've got that, let's first edit a source file. Actually, let's set this up to edit the Clojure script file. And that's not working. Okay, I'll do it later. I'll start the REPL. Let's just load up Emacs. Code demo dev. Okay, that's for later. And I'm doing that now because it's lining and it takes a while to load up. So it does take a little while to load up. It's because it's loading up not just the REPL but also all of the Duct supporting libraries. It's also using loading up things like Figwheel and stuff. So it will take a little while to load up. I'll adjust my headset a little bit. There we go. Okay, there we go. So once we're actually in the REPL, even though it takes a long time to start up, once we're in the REPL, it's actually pretty quick. So we'll start by starting things off. So this uses the reloaded workflow. By typing go, that's the same as initiating and starting the system. So you can see here it's loaded up Figwheel. Figwheel's compiled everything, and we've started. So we go to our browser and refresh, and if I zoom in a little bit so you can see, right, this is a static index page you get, and it sort of tells you what profiles you've got and how you can use them, and gives you helpful suggestions about running CLJS REPL. So let's do that right now. So even though this is a static page, it's connected back to Figwheel. So you can see on this side, let's try popping that up a little bit, and so you can see Figwheel has started. And if you go into here, type in CLJS REPL, then it's all automatically done for you. And just to prove this is an actual REPL to our browser, we'll do a JavaScript alert, and there we go. So it's kind of configured all for you, and we can even define things, perform arbitrary mathematics. And when we're done, we can pop back to the Clojure REPL. So this works as well with Cider, although you need to customize it a little bit. As well, although Cider and Emacs have got testings, and I believe Cursive has as well, if you like to use the REPL, it provides a test function for you, which this is a little bit. Let's try it again. Let's run it at a slightly lower resolution so it doesn't. Okay, there we go. So it turns out it's not so great if your screen is really small, but as long as your screen is not 50 characters wide, you get this nice bar down here, and the tests will run pretty quickly. When they fail, you get nice error messages. This is using ftest, which is a testing runner I wrote, and I'll show you Figwheel as well. So if we edit a particular file, so if we edit this file, let's so here is the file used when we start up. If we change it to add in some debug information and save it, then you'll notice that unlike normally with Figwheel, the moment you save a file, it produces it reevaluates everything. So Duct uses its own Figwheel implementation. So I've gone in, I've pulled Figwheel I didn't want, and it will only refresh Figwheel when you run the reset function in the console. So when I run reset, it compiles it and notifies the browser's changed, and you can see now Figwheel has reloaded. And the reason why it's not automatic is so that you can choose to make it automatic if you want. If you want it to compile every time you save a file, then you can add a watch. But if you don't want that, if you don't want it to keep evaluating things, particularly since the server and the client are usually in sync, so if you make changes to the server, or if you make changes to the client whilst you're making changes to the server, you may not want the client to reevaluate things immediately. You may want to wait until you've made the corresponding change to the server. And the reset function will reload both. So it reloads all of the server code, and it reloads all of the client code. And it's pretty quick, right? So if there's nothing to do, it's sort of instantaneous. And that's everything, I believe. So that's the end. Okay, are there any questions? Do we have time for questions? Okay.
What happens if you have an exception in your code, like missing something parent?
If you have an exception in your code and
then you want to reset the system, it's like
yeah. So we can put if you have an exception in your code and you try to reset, it will just throw the exception, but it won't reset anything. It'll just stop there, and then you can call reset again, right? So the reset function is something that persists across the environment. It's put in a separate namespace and told not to reload. So you should be fine with an exception. You'll just get the exception, then you could just fix the problem, hit reset again, be good.
The whole library seems quite abstract on top of the infrastructure. Is it still Ring middleware? Is it still synchronous calls? Is it netty? What's going on kind of underneath the component structure?
Okay, right. So underneath it all, it's Ring. So it's synchronous components. Although if you link it up to something like Aleph or some other thing which handles async, you can do it that way. But fundamentally, it's still Ring. It's not something like Pedestal, and it uses by default it uses Clojure for routing. But because we're just dealing with handlers, you could use Biddy or some other routing system just as easily. Does that answer your question?